guys, what's up? I'm Munot and welcome to the School of Physics. Today we are going to do the simple harmonic motion, and simple harmonic motion is one of my favorite chapters because it's all about imagination, very simple formulas. We won't go into phasors in this video, but what we need to solve any objective exam, we'll do everything. Okay, so today we are going to do simple harmonic motion. No, we are not actually going to do simple harmonic motion. We are going to study simple harmonic motion within a few minutes. So what is simple harmonic motion? First, let me make you imagine what a simple harmonic motion looks like. So here is this object, and this object is going here till A distance, and this say origin, and then it goes back to this position A. Like both the positions A are same. We call it positive A. Let's call it positive A, and let's call this negative A. Okay, why is the object moving like this? First here, then at some position it is here, then it is pulled back, and at some position it is here, and then it goes from here to here, and then it is pulled back, because a force of a particular characteristic nature is acting on it, and we say that this force, so suppose this distance is x-axis, this is the positive x, so this force is characterized by negative of kx. So if the x is positive, the force will act in the negative direction, and if the x is negative, the force will act in the positive direction. So this is what SHM looks like. And this force can also be known by this equation A sine omega t. Graphically, how does an SHM look like? Let me show. So it looks like a sine curve. Okay, and this is positive A, this is negative A, then this is again positive A, this is again negative A, so this is also A, and these angles are omega t. So when omega t is equal to pi by 2, as you can see from the equation, when omega t is equal to pi by 2, A sine omega t will be equal to A, right? Okay, so this is not the force equation, this is the position equation. So x is equal to A sine omega t. This is how SHM is defined. So when omega t is equal to pi by 2, x is equal to A, that is the maximum amplitude. When omega t is equal to pi, the x is equal to 0. When omega t is equal to 3 pi by 2, x is equal to minus A. So as you can see, when omega t is equal to 0, x is equal to 0. When omega t is equal to pi by 2, x is equal to A. When omega t is equal to 3 pi by 2, x is equal to minus A. When omega t is equal to pi, x is equal to 0, and when omega t is equal to 3 pi by 2, x is equal to minus A. So this is how SHM goes like. This is the x, right? Okay, so what is the time period for one oscillation? So this sine curve, as you know, this is one oscillation. So what is the time period for one oscillation? We write the time period as 2 pi by omega. Now what is this omega? Omega is the angular frequency, as we can see here. So this force can also be written in terms of omega as, m omega square x of negative, and we get a relation between omega and k. So what is this k? K is the constant for SHM. So f is equal to minus m omega square x. So this is going to be like minus of kx. So we can also write omega is equal to under root of k by m. X cuts, m comes down, omega square is equal to k by m, omega is equal to under root k by m, right? So this is what we do. So t is equal to 2 pi by omega, f is equal to under root k by m. The next thing that we figure out is velocity. So velocity at any point x, velocity in terms of x is written as plus minus omega plus minus omega under root a square minus x square plus minus omega under root a square minus x square. So as you can imagine, in SHM, when the x is equal to a, the velocity is going to be 0 and it is going to be pulled backwards. When x is equal to 0, the velocity is going to be maximum, Vmax is equal to a omega, and when x is equal to minus a, the velocity is going to be minus a omega. So the velocity is going to be minus a omega, right? Oh, I'm sorry. When x is equal to minus a, velocity is going to be 0. So the maximum velocity comes at this point, which is equal to Vmax is equal to a omega, which comes as Vmax is equal to a omega. Now, plotting the kinetic energy and the potential energy. So kinetic energy and the potential energy. So kinetic energy is equal to half mv square. So where do you think the kinetic energy will be? Where do you think the kinetic energy will be maximum? At this point. So maximum kinetic energy will be half m omega square a square. This will be the maximum kinetic energy maximum. Now potential energy is defined as half k x square. At any point x, the potential energy is going to be half k x square. Let us plot the graphs for potential energy and kinetic energy. So for kinetic energy, as we know, the kinetic energy is going to be maximum here and minimum at the corners, because at the corners the velocity is going to be 0. So this is going to be the kinetic energy curve, and the potential energy curve will be something like, so this is x, this is kinetic energy curve. The potential energy curve will be something like this. At x is equal to 0, it will be, at x equal to 0, it will be 0, and at the corners it will be the maximum. So at the corners it will be half k a square. Now what is the total energy in the system? So what happens is, as you can see, this is the potential energy curve. So as you can see, at x is equal to 0, kinetic energy is maximum and potential energy is 0. So all the potential energy gets converted into kinetic energy at x is equal to 0, and when the kinetic energy becomes 0, the potential energy becomes maximum. So what is the total energy? Can you just guess? Okay, it is going to be the maximum kinetic energy, and the maximum kinetic energy is as simple as that, is equal to here half v m v max square is equal to energy total for SHM is equal to half m v max square, which is a omega square, is equal to half m a square omega square, right? We move to the next part. This is all about how SHM looks like, and the next part is all about time periods. It's all about time periods. So we have a lot of kind of pendulums, and in a lot of exams, so all the exams, the previous papers that I have seen, questions related to time periods have come on direct formula. So this is very important. All these formulas that I'm going to tell in the next few minutes is going to be very important. So okay, so let's talk about springs. So suppose I have a spring. Now this is mass m and this has spring constant k. So if it is pushed x, right, so it will SHM. We know that it will SHM. So what will happen is that it will have a time period of 2 pi under root of k by m. 2 pi under root of k by m. So it will have a time period of what? 2 by under root k by m. That is 2 pi by omega. I'll just check 1 second. M omega square x square barabar kx. So x is equal to k by m under root, right? X is equal to omega square x. So x is equal to omega is equal to under root k by m, and t is equal to 2 pi by omega, T is equal to 2 pi by omega. So omega is under root k by m. So this is not k by m. So whenever you get confused, you can use this equation. It is 2 pi under root m by k. Okay. Now we have a pendulum. Let's say we have this two mass. We have this two mass m1 and m2. Now this is a system. This is a system. So when we do the SHM for this system, what will happen? What will happen? It will also do SHM. Now the point is, you need to remember this formula, very important. The time period for this will be 2 pi under root of mu by k. 2 pi under root of mu by k, where mu is the reduced mass, is equal to m1 m2 upon m1 plus m2. m1 m2 upon m1 plus m2 is the reduced mass. Right, so 2 pi, I'll just 2 pi by omega is the time period. 2 pi under root mu by k, where mu is equal to m1 m2 upon m1 plus m2, which is the reduced mass. Now the third type of pendulum that we are going to see is third type of SHM is a simple pendulum. So we have a simple pendulum, its length is L and this is this mass, right? So it does some SHM, it does SHM. So the time period will be equal to 2 pi under root L by G. The time period will be equal to 2 pi under root of L by G. Now we have another which other pendulums? Okay, so we can take a torsional pendulum. So this is a torsional pendulum. So what happens in a torsional pendulum is, so it is a body rather than a string, it is a body, and this is the axis. Whenever we hinge something, this hinge part becomes center of mass. Okay, and suppose we give it a force here, x here, and this is L, and at this axis the moment of inertia of this object around this axis is I. Now when this will SHM, this will SHM, it's called compound pendulum. When this will SHM, what will be the time period? So the time period will be 2 pi under root I by mgl. 2 pi under root I by mgl. Now what is this I? We remember parallel axis theorem. So in parallel axis theorem, we learned that I is equal to I center of mass plus this distance. Suppose the distance is L plus ml square. So we'll use this 2 pi under root I by mgl. The next type of pendulum that we'll see is torsional pendulum. Okay, so what happens in the torsional pendulum? In torsional pendulum, there's this thing. You might have seen that those toys you must have bought them in your childhood, which like if we rotate them like this, they rotate back. So that motion is also SHM. So suppose this is a disc and the moment of inertia around the center of this disc is I. So they'll give a constant called C. Which is the torsional constant. Now the time period, so if we rotate it, say some angle theta, then it will SHM. So the time period of this SHM will be equal to 2 pi under root of I from the center of the disc upon C, where C is the torsional constant. So we have learned about the time periods. The next thing that we are going to learn in SHM is superposition of two SHMs. Okay, so superposition of two SHMs. Direct questions come from this. We just have to remember the formulas. Very interesting if you imagine. So when two blocks are doing SHM and we combine them both, then what will happen? if two blocks are doing SHM and we combine them both, then what will happen? So what will happen is that it will actually do another SHM, but the point is that the angular frequency of this SHM is going to remain the same. But what will change? What will change? Just imagine. So the thing that will change is the amplitude. So suppose I have one SHM, or first let me tell you visually. So this is one SHM going on and this is another SHM going on. Say we write it as x1 is equal to a1 sine omega t. Okay, and this is another SHM going on. This is another SHM going on, and we write it as x2 is equal to a2 sine omega t plus a2 sine omega t plus theta, right? So we have these two SHMs. So the new SHM will also be of the same frequency. What will change is the amplitude. And how will that change? What will be the resultant amplitude? We have to remember it is equal to under root of a1 square. So we can recall from the chapter of vectors that if this is a1, if this is a2, then the resultant a will be from here, and if the angle between a1 and a2 is theta, if the angle between a1 and a2 vectors, so this is a vector, this is a vector, this is a vector, and this is a vector. So if the angle between a1 and a2 vector is theta, the resultant a, the magnitude of resultant a will be equal to a1 square plus a2 square plus 2a1a2 cos of angle between them, cos of theta. So this question will be directly asked. It's asked a lot of times. So superposition of two SHM. Okay. So but what will be the angle alpha? So if we have to, you know that to locate a vector, we also need the angle, right? So, we can have the magnitude and then we also need the angle. So what will be this angle alpha? So this angle alpha, we can write it as tan alpha. So when we are seeing the angle alpha from A1, so we can write it as, what is tan alpha? It's sin alpha upon cos alpha. So we can use the same concept. It's when it is from A1, tan alpha is equal to a2 sine of theta upon a2 cos of theta plus a2 cos of theta. So this we write tan alpha tan theta. Now this is the trick. When it is asked tan alpha and it is from a1, then we write what is tan theta for a2. It is a2 sine theta upon a2 cos theta. And in the denominator we are going to add a1 simply. We are going to simply add a1. So guys, this was the chapter of SHM. I hope you enjoyed it. Very simple chapter, formula based questions, and I'm sure you can do all the questions that will come up in exams if you just follow this video, revise this video. Please subscribe to my channel so that I can make more videos like this. Thank you. Love you all.